This is the SIFT display window. So I downloaded it from the download site, unzipped it and untarred it, and it starts like this. First thing you want to do, you can play around with it with the roller wheel. First thing you're going to do is load some data. So this is data from class that I've requested and downloaded. I'm going to load bands 15, 13, 2, and 1. It'll load. It takes maybe a couple seconds for a band. Band 2 is the half kilometer, so that takes a little bit longer. You'll notice you can zoom and pan pretty easily. It's seamless. There's no real issues with that. Lambert conformal's default. I'm going to change the projection here to Ghost East and zoom in on this region in Kansas where it looks like there might be some blowing dust. So this is a region we want to investigate a little bit further. One of the things you can do is right-click on the image, and that probes the data. So you've probed all 4 bands that are there. We're animating it now. If you right-click on that, you can change the animation speed so it's not quite so fast. So we have a region here where band 13 is cooler than band 15, and band 1 is a little bit more reflective than band 2. Let's move that area probe display inside just to conserve some space. So if you look at the different values here, those are all values that suggest that maybe this is actually dust. Now, one of the things you can do is create what's called an algebraic. So I'm going to make a difference field. I'll just call it the split window difference because that's what it is. The operator is a difference. And we're going to take a difference between band 13 and band 15. And you do that and it creates the values. First thing you want to do is change the color mapping. There are a lot of color maps that are installed with SIFT. So we're going to look for the one that goes with dust and the split window difference shown here, and then change the bounds. So the default bounds are -164 to +164. We're going to make it -6 to 8. And when you do that, you get something that looks like that, and you see a feature here, the dark brown, is kind of highlighting the region that you saw in the visible imagery where it looks like there might be blowing dust. You can also create a region by just clicking. These are right clicks, creating a polygon, and to close the polygon you simply you re-click on the first polygon, and you notice in the upper right there we now have a bar graph that's of the split window difference. We've popped the area information, probe information in. We'll move the bar graph into the image now. That red line shows you where the probe is. So we're looking at the split window difference. That's just a bar graph. Doesn't give you a whole lot of information. We're going to change this to make it look at band 13. I'm going to look at band 13 versus band 15. You notice it does these plots pretty quickly. That's kind of nice. Plot's a little bit small, so let's make it a little bit bigger. And you uniformly see a region where band 13 brightness temperatures are cooler than band 15, which is what you expect with dust. You can also look at band 1 versus band 2 reflectance, and you'll notice that band 1 reflectance is a little bit higher than band 2, also a signature of dust. So this is how you can use SIFT briefly to detect dust.